Biological evolution has two big ideas. One of them has to do with how the process occurs, and that's called microevolution. It's evolution going on right now. Evolution is going on in your body right now. You've got about 10 to the 13th bacteria in each gram of your feces, and they have enough mutations in them to cover the entire bacterial genome. Every time you flush the toilet, you flush an entire new set of information on bacterial genomes down the toilet. It's going on all the time. Now, the other major theme is macroevolution. This process of microevolution has created a history. And the history also constrains the process. The process has been going on for 3.8 billion years. It has created a history that had unique events in it, and things happened in that history that now constrain further microevolution going on today. That's one of the tricky things about evolution. It has many different scales. My wife always gets frustrated with me. She says, well, when did that happen? I said, oh, not too long ago, only about 20 million years. And, you know, that's what happens when you become an evolutionary biologist. You zoom in and out of deep time a lot. So, where did this idea of evolution come from? Well, there are always ideas. You can go back to Aristotle and find elements of evolutionary thought in Aristotle. But really, it's a 19th century idea. And in order to see how it developed, let's go back to about 1790 or 1800. So at the end of the century of the Enlightenment. At that point, if you were to ask a well-educated person living in a Western culture how old the world is, they would say, oh, thousands of years. And if you were to ask them, well, where did all these species on the planet come from? They would say they were all created just the way they look now, and they've never changed. And if you ask them, have there ever been any species that went extinct? They would say no. Everything that was created is still alive and can be found somewhere on the planet. So when Alexander von Humboldt, who was certainly a creature of the Enlightenment, sets out to explore South America, he thinks that he might encounter some of those strange fossils that the French have been turning up in the Paris Basin on top of a tepue in Venezuela. So he really thought that there was a lost world. Of course, Arthur Conan Doyle later wrote a novel about that. But I mean, these guys actually thought, hey, I go to Venezuela or I go to the Congo, I might meet a brontosaurus. That was what they thought at that time. They thought that adaptations were produced by divine intervention. They did not think that there was a natural process that could produce anything that was so exquisitely designed as your eye. We now know that your eye is in fact very badly designed, but it looked pretty good to them. Anybody here know why the eye is badly designed? What's wrong with your eye? It's got a blind spot, and it's got the nerves and the blood vessels are in front of the retina. The eye has to go through the light has to go through the nerves and the blood vessels to get to the retina. The octopus has a much better eye. Okay, now by the time that Darwin published his book in 1859, people thought that the world is very, very old. How old, they weren't sure. We now know about 4.5 billion, but at that point, based on the rate of erosion of mountains and on the saltiness of the ocean, assuming that the ocean had been accumulating salt continuously and that it hadn't been getting buried anywhere, which it does, people thought hundreds of millions of years. They weren't yet in the billions range, but they thought hundreds of millions. They knew that fossils probably represent extinct species. That was Cuvier's contribution. He did it for mammal fossils in the Paris Basin. Geoffroy Saint-Hilaire had had a big debate with Cuvier about homology, and that was in 1830. By the way, it was one that many people throughout Europe followed very closely. This was a very, very key intellectual topic at the time. And it was about homology. Basically, it was about the idea that Geoffroy Saint-Hilaire had that if my hand has 5 fingers, then and a bat's wing has 5 fingers, and the fin of a porpoise has 5 fingers, that indicates that we all got those 5 fingers from a common ancestor, and therefore we are related because we had a common ancestor. So you can see that in 1830. That's before Darwin publishes his book. Okay. Then, of course, we have the idea that adaptations are produced by natural selection, and we owe that to Darwin. And I will run through the process he went through between 1838 and 1859 very briefly. This is one of the most important ideas about the nature of life and therefore about the human condition that's ever been published. And I strongly recommend that if you have a chance, read The Origin of Species. Darwin actually was quite a good writer. It's Victorian prose, so it's a little bit like reading Dickens, but it's good stuff. He has a nice rolling style. How did he come to it? Well, Darwin was a med school dropout. Went to Edinburgh, didn't like med school, loved beetles, and became passionate enough as a naturalist to become known as a 22-year-old young man as a guy who might be a good fellow to have on an expedition. And the British Admiralty was sending Fitzroy around the world to do nautical charts, and Darwin got on the ship. So at an age not very much greater, or perhaps even a bit younger than some of you, Darwin sets off. He's 22 years old. He wants to know how species form. He has set himself that goal. So he's ambitious. He set a clear goal. The goal is to solve one of the most pressing problems that biology has at that time. Where do species come from? Now, the stimulus that he has is in part from Charles Lyell, the geologist, who had discovered deep time. And that convinced Darwin that there would have been enough time. He stops in Argentina. In the banks of a river in Argentina, he can see giant fossil armadillos, and then right on top of that same bank, he can see the current armadillos walking around up on top of the bank. There they are. The live ones are right above the fossil ones. They look the same, but, I mean, they look similar, but they're not the same. So there's some connection there. He gets on a horse in Chile, and he rides up into the Andes, and he sees marine fossils lifted thousands of feet above sea level. Clearly, some dynamic processes going on that had lifted those marine fossils up. He doesn't know about continental drift yet, right? But there the fossils are. In the harbor at Valparaiso, he sees the effects of an earthquake that had happened just before they arrived. It was a big one. It was probably as large as the earthquake that recently caused the big tsunami in Indonesia, so it was probably an 8.6 earthquake. And it had caused an uplift in the harbor of maybe 50 feet. So he began to see the world as dynamic. Things hadn't always been the way they are. Then he goes to the Galapagos. And please navigate the Galapagos website and have a look at some of these differences. The thing that Darwin noticed is that the mockingbirds are different on the different islands. If you go to the Galapagos, what you'll notice is that if you land on Hispaniola, the mockingbirds really want your water supply, and they will hop onto your head or your knee to try to get at your water supply. But in fact, the mockingbirds all look a little bit different on the different islands, and that's what Darwin noticed. He could also see that the marine iguanas look a bit different and the land iguanas look different. Interestingly, he didn't notice the differences in the finches until he got back to England and gave his collection to the British Museum, and the ornithologist at the British Museum came in and said, "Hey, Darwin, do you realize that the finches on these islands are different?" And that was when he began to really see how many differences could accumulate, how rapidly, when you take a migrant from Central America and put it on an isolated archipelago. So he goes back to London. He's been on board ship for about 4 years. He has a problem with seasickness. He never again sets foot on a ship. He doesn't want to go near the water after being 4 years on this ship. He had a few issues with the captain too, Fitzroy, but mainly it was that he had a very bad upset stomach on board the Beagle. He reads the Reverend Malthus on population growth. Malthus's book had come out in 1798. Malthus said basically that populations grow exponentially, but agriculture grows linearly, therefore populations will always outstrip their resource base. This convinced Darwin that all organisms are in a competitive struggle for resources and that that must inevitably be the case. He saw very clearly how powerful reproduction is at generating exponential population growth. We will come back to that in the ecology portion of the course. And we now know that organisms are in competition really essentially not just over food resources, they are in competition over anything that will get their genes into the next generation. So that can be competition for mates, it can be competition for nesting sites, competition for food, lots of different things. But at any rate, this primed Darwin's thinking. So he writes down the idea of natural selection. It comes to him in 1838. It's in his notebooks in 1838. Basically, I'll run through natural selection in a minute. It's a deceptively simple idea because the mechanism looks so simple, but the consequences are so wide-ranging. Darwin recognized what the consequences were, and he didn't publish immediately. He did other things. He went off and he worked 5 or 6 years on barnacles. He wrote down lots of ideas about things unrelated to natural selection. And he wasn't really jogged out of this until a letter arrived in 1858 from Alfred Russel Wallace, a young British naturalist who had, in a fit of malarial fever, had the same idea in Indonesia. And Wallace knew that Darwin had been thinking about these things, and he sent Darwin a letter. And at that point, Darwin, British gentleman as he was, had to decide whether he would do the sort of gracious, honorable thing and let Wallace have the idea, or do the honest thing, which his colleagues knew, was that he had already had the idea. And what they decide upon is that they will do a joint publication. So if you go to the Biological Journal of the Linnaean Society for 1858, which is in the Yale Library, you can look up the back-to-back papers by Alfred Russel Wallace and Charles Darwin in which the idea of natural selection is laid out. And then Darwin rushes his book into print. So he has been working on a book that was probably going to be about 1,200 pages long, and instead he publishes an abstract of it, which he calls The Origin of Species, which is about 350 pages long. And it sells out on the first day, sold all 6,000 copies on the first day, and it has remained in print ever since.